Bonjour, je m'appelle Tiffany, je travaille à VMware. Malheureusement, mon français est très mauvais, donc je vais parler en anglais. If you understood that, yay, because the person I talked to yesterday asking for water, I accidentally swapped peu and vous, and he gave me a pardon. So my French, not there yet. So thanks everyone for coming. As you can probably tell by now, this talk is in English. So otherwise, it would not work out so well. So basically, the goal of this talk is to give folks like high-level understanding, if you don't already have it, of cloud-native security for folks that aren't already like super into security or want to teach other people about it. So yeah, developer advocate at VMware. If you use Twitter, that's my Twitter handle there. And we get to find out if my clicker works. Sweet. Okay. So just diving right in. So basically, less is more. So basically, the less that you have, then the more secure that you can end up being. So for instance, have less code, where it's possible maybe try to use some sort of managed services that are existing or like existing security solutions instead of trying to go and create your own. Also, if you take something off the shelf, chances are they're probably, unless you like hire your own specific people, there are probably more people working on it. So therefore, it's probably better. Also, try to make sure to give fewer permissions. For instance, only give necessary permissions and try to avoid giving long-lived secrets. So don't give someone the equivalent of root access, for instance. Not exactly the best idea. Also, try to have fewer dependencies to try to minimize the attack surface. So for instance, maybe you would want to use some sort of distroless image instead of using Ubuntu. And then also try to keep up with some of the latest recommendations. So there's a link there on the Kubernetes docs that has a security checklist. So every so often you can go and look at that and check up to see what is on there. All right, so I took this off of the Kubernetes docs. They call these the 4 C's of cloud native security. So there is cloud, which could also be like your corporate data center or colo. Then there's cluster, container, and code. And as a practitioner, you need to think about hardening your infrastructure at every single one of these layers. First, I'm going to start talking about some of the cluster components. So unless you really need to go and run everything by yourself, I suggest that you don't. Instead, try to find some sort of managed Kubernetes offering. These managed services, they take care of a lot of stuff for you so that you don't have to worry about it. I'll get into some of the things that it does a little bit later. And with these managed services, security and hardening is one of the like primary value additions there for these cloud platforms. So again, with hardening, make sure you harden the control planes. So only let people interact with the API server via the Kubernetes APIs. And the less you have running on your control plane servers, the fewer potential avenues like an attacker could have to exploit to gain access to your cluster. Also, make sure that you use real TLS certs. So you could get that from, say, Let's Encrypt. And please don't be lazy and use this lovely flag here that's insecure skip TLS verify. It's basically as good as just not using TLS at all. There is also this talk by Tabby Stable, which you can see a link that goes to a GitHub with slides and other stuff about it there. And it's called PKI the wrong way. So in that, it's basically demonstrated how the end user's ability to create client certificates for MTLS can be leveraged to gain complete control of a cluster. So etcd by default assumes that anyone that can successfully authenticate with MTLS has proper access, which isn't necessarily the case. So to avoid this, you need to restrict access to etcd, and if you look into some of the Kubernetes docs, it also tells you how you can go about doing that. All right, so continuing on that front a little bit. So there is another thing that you need to worry about, which is with pod security. So make sure to use pod security standards to prevent others from having access that they shouldn't have, such as like root access to your nodes. So pod security policies, or PSS, pod security policies, or PSP, there are too many acronyms. They were the default until 1.21, and then that got deprecated in favor of PSS. There's a lot, and there's PSA as well. And then if you're using Kubernetes like on some sort of cloud provider, you have to deal with the cloud metadata server. So this is where credentials and info are given into the virtual machine. You basically almost never want the pods to have access to it. It can result in a lot of pretty scary vulnerabilities. And if attackers could then have access to the metadata server, and therefore they could potentially gain access to credentials associated for like the VM account. So basically, like if you have a pod and that pod can gain access to it, it can get the node credentials, and then someone could maybe like try registering into the cluster. So with some amount of like work, a pod basically could be like, hey, I'm a node, and get workloads assigned to it, which can be pretty bad. So with Kubernetes, please make sure you update Kubernetes and aren't super, super far behind. Like with these managed services, they make it a lot easier to be able to go and do updates. So for instance, like it's not like how it used to be back when you had to deal with OpenStack, for instance, where you would go and be like, here, let me create a new cluster. Here, let me move all my stuff. OK, now let me delete my old one. You don't have to go through that entire process anymore. And just so many people nowadays are on very old versions of Kubernetes, because I understand sometimes it can be easier to just not change anything or do anything. But like with some of these managed offerings, for instance, you can maybe have there's sometimes a button that can help you with upgrades. Sometimes there's even auto upgrades. It's just one thing that makes it easier. And it's really important to do this as new like CVEs or vulnerabilities are being found, to like make sure that you are having a more secure cluster and environment, both for yourselves and for the people that are using your things. And if you're worried about, oh no, what could go wrong with this upgrade? Well, chances are it's probably going to be fine. Like there's actually probably more likely an issue that you're going to run into with deprecation cycles and upgrading that's needed with that. So like here is a little example of something that upgrade that already happened. So for instance, this is with Ingress. So at one point it was at V1 beta 1. So they were saying, okay, here starting in 119, like we're going to be doing upgrading. We're going to be going from V1 beta 1 to V1. And starting in 122, then V1 beta 1 is going to be removed. So you don't have to worry and be like, oh no, like the world's ending. I need to like drop everything I'm doing and deal with this right now. You basically actually, looking at it, have about a year to deal with this. So don't really have too much of an excuse to not move forward at that point. All right, so if you are dealing with your entire cluster yourself and not using any form of managed offering, this is basically the step of things that you have to do for upgrading a cluster yourself. So first you have to go and upgrade the control plane. Then you need to upgrade all of your nodes, then clients such as kubectl. And then you have to deal with like adjusting like manifests and other resources that are based on API changes that accompany that new Kubernetes version. So as you can see, that can be kind of a lot. I mean, there's only a few lines on there, but the actual work done to do each one of those can be pretty time consuming. There can be things that might go wrong. So ideally, again, if you have the ability to use the managed offering of some sort, try to do that so you have less to worry about. All right, so let's talk a little bit about isolating a compute. So there's these things of quotas and limits, and they can be basically used so like noisy neighbors don't affect other workloads on the same host. So they can, for instance, prevent like an attacker from using your infrastructure for like DDoS or crypto mining and whatnot. There's also taints and tolerations. So you can decide, hey, I don't want these workloads running on the same nodes as these workloads, for instance. And then if you want to add another layer of security, you can deal with some sort of sandbox container runtime, such as like gvisor or Kata or Firecracker. So they basically add another layer of compute isolation between your containerized workloads and the underlying OS kernel. So that basically is adding another layer of virtualization. So by default, in Kubernetes, like there's just this flat network layer where every single pod can talk to every single other pod. If you do not want all your pods being able to communicate with each other, then you need to have network policies. And there is a link to the Kubernetes docs up there. So Kubernetes also has this assumption that you trust this underlying network. So for example, that network could be the network of, say, your cloud provider, if you're using a cloud provider. If you don't trust them, then obviously you need to do something about that. So one way to address that is to end up setting up like a service mesh, for instance, with like full end-to-end encryption, for example, with MTLS. Some people might say that is overkill, but it all depends on what you specifically need. You could additionally go the extra mile and use a tool, something like Cilium, and use that for advanced network policies, such as like applying filtering on specific API routes. For example, you could be like, hey, allow my pod, which is some name front end, to talk to this endpoint for v1/users, but I don't want it to be able to talk to, say, v1/billing. And you can do that using this lovely magic with eBPF. All right, so secrets. So secrets can have different sorts of RBAC permissions. If you want to go really hardcore, you can also encrypt them at rest. So Kubernetes supports encryption at rest, which basically will encrypt resources like secrets and etcd, which basically prevents like specific other like parties to gain access to your etcd backups, which would not be good, and viewing the content inside of those secrets. Also, please do not directly put your secret data inside of a config map. Actually put it into a secret and then have your config map address that secret. And to take it another step further on top of that, don't actually put stuff directly into secrets. Use something that will do that for you. So the whole point of this is to avoid accidentally committing something up to GitHub with my secret data. And now everyone can see it. Maybe you didn't even realize it, and bad things can happen. Obviously, you might think that, again, be obvious, but like mistakes happen. So unless you really need to, don't manage them yourself. You might want to use some sort of like key management service, such as like HashiCorp Vault or Sealed Secrets or Casmus or SOPs, or if you're using a cloud provider, they usually have some sort of KMS as well, and just using that for your secret data encryption. Basically, this whole idea is a lot of like leveraging the work that other people have done to make your life easier instead of trying to do each of these things yourself. All right, so now I'm going to be talking about user management and permissions. So people, I assume that mostly is you all, and your devs. There's also robots, which are more like automated services and code running on your clusters. I assume no one here is a robot. I don't think we've gotten that far yet. And these things all need to talk to the Kubernetes API so that they can go and do things like deploying things, being able to scale up and down, roll out new versions, like view logs, basically do all of the things. But we don't want our autoscaler to be able to do something like, oh, hey, I'm going to go like mine Bitcoin, or maybe some developer got angry and they're running away with data from some credit card database. Well, that's probably more likely that someone got their laptop stolen or something like that, which may have happened to me. But no one got in, I think, so we're good on that front. But just like make things harder to get access to. But basically, because of all this, I'm going to be spending this whole next section talking about this topic. And to go a little bit further, I have a talk at the meetup tonight, which I have a slide on, which is I'm also doing tomorrow at the conference that dives more into this whole section of like service accounts and RBAC and whatnot. All right, so there's two different forms of auth. We have AUTHN, which is basically like, who are you? And then there is AuthZ, which is authorization, and then that basically is like, what are you allowed to do? So first I'm going to go into AUTHN, or authentication. So Kubernetes is pretty flexible here. Like you can do things like, hey, I want to use TLS certs. Maybe you can, with your own like certificate authority, or maybe not. You can use OIDC tokens with any OIDC provider. So perhaps maybe it's something like Dex or Keycloak or something like Okta. And then that can in turn be plugged in if you're using a cloud provider with that cloud's IAM. So for instance, you can map cloud provider users to Kubernetes users, which is pretty cool. Please remember to constantly think about the Kubernetes and just security in general best practices. So like prefer using short-lived secrets. Like for example, you might want to use OAuth access tokens instead of having a user and password, because then you have to worry about manually going and changing that if someone ends up getting that. And then there's that breakdown that I kind of mentioned a little bit earlier. There's the humans and the robots. So for humans, you may end up using like TLS, OIDC, service accounts, etc. So just like as like a little fun note, in Kubernetes, you don't do this, hey, let me create a user. Instead, you are like, hey, let me create pod permissions to say, like, I'll give it to Jerome. And as long as like someone shows up with a valid cert or OIDC token for Jerome, then they can create pods. And then there's robots, and that usually uses service accounts. There's also this project called Spiffy, it's spiffy.io, which you can use for authenticating from one service to another. It's kind of an advanced use case for like with short-lived identities, but yeah, it may be something that you specifically want to do if you want to look into that. So now authorization, or authz. So this again is, do you have the permission to do what you're trying to do? For instance, do you have permission to create pods? Do you have permission to view what's running in the cluster? Just like any of those types of things. There are a few different types of Kubernetes API server authorization modes. So there's node, which is like a special purpose like authorization that grants permissions to kubelets based on the pods that they're scheduled to run on. There's ABAC, and as you can see, there's a lot of acronyms, and that's attribute-based access control. There's also a webhook authorization, which allows you to use a custom authz system, such as like plugging in whatever existing system you might already be using. And the main one is RBAC, which is role-based access control, which is what I usually hear people talking about and what we're going to be looking into next. So the high level of RBAC with Kubernetes is you basically, hey, I'm going to define a role. And that is a collection of some sort of permissions, like things that can actually be done. So for instance, it's like, hey, can I list pods? Can I create a deployment? Can I see what is running in this specific namespace? Just like all the different things that you can do. And then after that, you end up binding whatever role that is to some sort of user, a group, or a service account using a role binding or a cluster role binding. So like the role binding usually is specific to a specific namespace, and the cluster is cluster-wide. After you create those types of things, you can actually go and check to see, hey, did I give the actual permissions I think I did? Because that's pretty important. So there's a built-in one if you're using kubectl, which I assume most people have. I guess who here has used Kubernetes? I should have asked that in the very beginning. All right, most everyone. Okay, cool. Yeah, so the main one is kubectl auth can I, and then you can do like a -- list and basically see all the different things that you can actually do. I'll be doing some of that in the other talk that I have, since that one will be like half demo. There's a bunch of these other ones that other providers have created as well that you can look into as well. But yeah, basically make sure to audit your RBAC, and so that you don't find out later that you just gave a bunch of access that you didn't mean to. And another thing is you can't take away permissions. It's like, for instance, you're like, hey, I want someone to have access to updating deployments, but you can't be like, except for this one deployment. So you have to go with like, I want them to have this deployment and this deployment, this one, and avoid like the ones that you don't want, for instance. Or you can just make separate namespaces and give them access to one namespace. So yeah, namespaces versus cluster-wide. So permissions can be defined either for the entire cluster or to specific namespaces. You could give someone access, for instance, to a specific namespace. They could even be an admin in that namespace. You could be like, here is like Tiffany's namespace, and we don't trust you, so you can have access to do this. You can blow anything up in there. If you break it, sucks for you, but you can't do anything in Devoprod, for instance. Also, yeah, don't give admin permissions to just anyone. That's basically like giving root access, I mean, a lot of people have heard for years, don't give root access. This is the exact same thing. Don't let anyone just do whatever they want with your cluster. Again, namespaces, basically, it makes it easier to be lazy. If you're wanting to just lock things down to only these people can access this namespace, only these people can access this namespace, to at least make it a little less chaotic. So software supply chain. So supply chain, the terminology has been used for a lot longer, really, than just specifically to do with software. So it's a little, I guess, graphic in a way, but in 1982, there were the Chicago Tylenol murders. They basically could not figure out, like, at what point along the pathway was something being put into the Tylenol tablets. So in the end, their solution was, all right, we're going to put a seal on it. But, like, for instance, you could have, like, transportation. And with that transportation, you're trying to avoid a person in the middle attack. You have your factory, which basically you can think of as, like, your CI/CD pipeline. So you could think of that one in a sense of, hey, maybe in software, maybe I'll have two CI/CD pipelines doing the exact same thing. So that way you can at least verify, is something happening to one of them, or, like, is expecting basically that they both do the same thing. And if something doesn't, you know there's something wrong with your CI/CD pipeline. You can also then check at the end, okay, if I have some binaries that are created, are these binaries the same? If not, something's wrong there. And then there's, like, threat modeling. So basically identifying, like, who the actors are in the org. Like, maybe it's some sort of disgruntled employee or just anyone. Just trying to go through and figure out what it could be. So with software supply chain, so, like, say there's some new vulnerability that gets disclosed. Like, how do you, one, determine, hey, am I actually being affected by this thing? And if I am, how do I go about deploying, like, some sort of fix or mitigation? Like, how do you even know that you're not accidentally running or, like, that someone's basically running some sort of Bitcoin miner and you just have no idea that this is happening? Basically, you can't be confident in your software unless you know exactly where everything along the pathway, like, where it came from who it's from, and how it got there. So some things that you may want to go about doing is you would want to restrict the paths that code can take from, like, your source repo over to production. You want to make sure that you're actually tracing, like, deployed code back along each step of the supply chain. Like, initially, like, where is this code coming from? Looking at things like OWASP for checking your code. Like, there's just so many, like, little steps here that you're going through, and at every single one of those, either accidents could happen or there could be some sort of bad actor trying to do something to mess things up along the way. So there's basically a number of questions that you need to be asking yourself, or, like, things that you need to be validating as you go from, like, writing code and actually running that in production. Generally speaking, you shouldn't just be like, here, let me write this code and immediately throw in production. Bad things could happen. So first off, like, if you see some sort of code change, did that change come from someone that you actually trust? So one tool that you can use here is Sigstore's git sign. You can use that to sign commits, identifying, like, who you are. And it's keyless, so you don't actually have to worry about GPG keys. You can also use Sigstore's cosign if you wanted to for, like, signing container images. And then next, like, is the source code coming from your source repo? Are you actually getting this from the right place? Because you could be pulling something that someone slightly maybe they changed one letter, and you think you're pulling the code, but it's actually some other person made it, and they know exactly what they're doing to get something they want from you. And then can only authorize people push to it. You don't want just any random person being able to push code up to your repo. And also, that's another thing with both authorization in general, and also just, like, the idea of having, like, multiple people approve, or at least one person approving someone's PR before you shove that up. And then next is, like, so when you are building your artifact, like, what you are building, is that actually coming from some trusted source? Like, is the build system itself actually trusted? Like, did something happen with the build system? Can you basically, like, trust, like, where it's, like, where you're running it? and whatever it is that it's actually running on. And then once you actually have gone and built this artifact or a program or whatever, can you trust that wherever you're going and pushing it to is like where you think it is, and that only trusted people can actually go and push to that location? And then ideally, it's only your CI/CD pipeline that can go and push, not just a bunch of random people. And that way it's going through this entire process that you have set up that every single time somebody tries doing it, it's the exact same way. And then also for like every step of those things, there's another, I guess, tool project called InToto that also helps for a bunch of tasks along the way for supply chain security. And it's just in-TOTO, which I thought I had added in here, but looks like I haven't done that yet. Also, so you have to worry about specifically with containers, with the images that you have there. Are you doing vulnerability scanning to look for like known CVEs? There's a bunch of different tools out there, such as like there's Claire, there's Trivy. Some of the container registries out there, such as like the open source one for Harbor, have this thing built in. Because there's maybe your code doesn't have anything, but maybe some image that you're pulling in originally might have something wrong that you actually care about. But there's also tons of CVs out there. You need to actually pay attention to what matters to you. I don't think it's really possible to be like, there will be nothing out there that in all the code there is. You should also consider some form of OPA implementation for policy enforcement. So there's Gatekeeper as one of the options there. Sigstore also provides an admission controller to assert image signatures and attestations as well. So here are some example. It looks so different on here versus over here, but some example actual like threat models that have happened and like how to go about them. So like for instance, like the question first off is like, who's your attacker? So like say someone makes change to some code, for example, that you depend on, and now that causes all your stuff to break. I mean, that's probably what often happened if you aren't specifically dealing with like vendor dependencies. And like whether it's the maintainer made some change and it no longer works for you, or maybe it's actually some sort of bad actor and they intentionally screwed stuff up or they deleted it. Like there's that like widely known example of like left pad for like an npm package, and it's just gone. So the suggestion there basically is to have immutable dependencies. Like, are you vendoring your dependencies, or are you effectively giving someone else arbitrary write permissions to your code? Like, they can't necessarily change specifically what you are doing in the code that you wrote, but if you're pulling in this other dependency and they change that, that is effectively changing your code. There was also this build infra attack on SolarWinds. So there was code that was produced by the build server that had malicious code that was injected into it that allowed external access. They were basically able to inject malicious code and sign it with SolarWinds signing key, which not good. So one way to avoid dealing with that issue is to have ephemeral builds. So basically don't have just a dedicated machine that someone can go and hack into. Basically, have a build system that spins up on demand, for instance. So it's only there when you specifically need it. Basically, if it doesn't exist, you can't hack it. So while it's not there, nobody can do anything with it. You can also have hermetic builds, so builds that don't have access to the outside world and can only do stuff with the code that is provided to it. And then that can't actually make any network requests. It's basically fully air-gapped. And then also make sure that your builds are reproducible. So a few more things that didn't exactly fall into the categories of things that I already went into. So there are some additional components. So like, long story is like, say if you spin up a cluster on some sort of web console, for instance, or maybe you go and use ekctl create cluster. The result there is actually far from being production ready. I did add the link there. So Matthias Hösler and I have a talk basically about getting to production readiness. It's how to make Kubernetes rhyme with protection readiness. It is on Friday at KubeCon if anyone is going. Is anyone going to KubeCon? All right, so a few people. But yeah, 2 something on Friday. I think everyone's going to be checked out by then, but who knows? So yeah. Anyway, so yeah, there's a few other things. So there's things like backing up your cluster. That can be really important. So for instance, maybe something went wrong and you want to go be able to backtrack like 2 hours ago, 2 days ago, or whatever it is, and not have to, I mean, yes, it's good to know what went wrong, but like if you're not trying to spend all time for exactly what went wrong to be able to go to exactly the state you wanted, having backups is useful. So there's an open source project called Valero that helps back up your cluster. You could also use it for doing something like migrating your what's running on your cluster to another cluster. It can also back up persistent volume claims as well. So another big thing is observability. Metrics can basically help you determine if something is going unexpectedly or help you try to solve it. If you there's the thing of knowing, hey, something is going wrong. But if you aren't able to figure out what is causing the thing to go wrong, it can be extremely hard to fix, and it's not a good idea to just ignore it. Also in the same vein, don't mind me. Also in the same vein is to make sure there is good logging. So good logging is super indispensable for good security because we want to be able to like audit who is doing what. So we want to be able to see things like what user did X and like whether maybe there was a change in like privileges or maybe there's some new privileges that are created. You want to be able to see when all that stuff is happening. You want to be able to see things like security events. You want to be able to see things like other interruptions to logging, like did logging just stop for a bit here? And that happens to be exactly when something went wrong. Like you need to use, there's a bunch of different tools that you need to basically make sure that things are going right and figure out how to fix them that aren't all set up there by default. And also, don't forget about your code itself. I kind of said that a little bit earlier, but make sure to do things with like source code analysis, for example, using OWASP. So you can go to OWASP.org for that, because a lot of the times people think specifically about, oh, well, here's my application that's running. Here's my container. And just like thinking about just the containers level to Kubernetes level of things, but not what about my code itself. I had a note to add more stuff to this list, which I apparently only had as a note because I spent yesterday napping after my train got here, 2.5 hours delayed. So there's the CNCF landscape. Who here has looked at that recently? Okay, not a ton of people. Who has looked at it at some point in time in their life? Slightly more, okay. If you look at it, if you're one of the people that did this slightly long time ago and not recently, if you look now, it's probably exploded a lot. My coworker, Josh Long, likes to describe it kind of as fractals. It just keeps getting bigger, and you can dig into it more and more. I spent a little too much time looking through it the other day for my KubeCon talk. Then the Kubernetes docs, they have a lot of information on there as well. There's an entire section there that's specifically just like for security. There's things there for if you're dealing with your own cluster and creation and all the stuff like on your own and not managed of the things you need to specifically worry about for having security there as well. There's sigstore.dev, and as I was mentioning earlier, there's also things like intoto, which is also like, I think it's going to be part of the CNCF. It's like either sandboxed or incubating or I think it's incubating. And then, okay. So I mentioned a little bit ago. So the talk that I am doing both tonight it's called a BOF, even though it's not a BOF, but it's the Kubernetes meetup. It's in this building. So I have the talk on the right, which is Beyond Cluster Admin, Getting Started with Kubernetes Users and Permissions. So yeah, basically diving more into the second part of this talk, and then actually like showing you creating like service accounts, giving people permissions, and just like diving into all of that instead of just slides and talking at you. So you could, if you feel like joining, you can go either of those. And then Jerome here also has a talk at the meetup tonight that's in French. It's in French, right? Yeah, correct. So you don't have to be stuck with just listening to me in English. And that's for machine learning, and it's pretty cool. So yeah, merci beaucoup. I was asked about not mentioning zero trust architecture. So one thing I guess I should have mentioned going into this is all the stuff that's on there is stuff I was like, hey, I don't know security. I want to learn it. So I started going through it, and this is my things that I learned. And therefore, that is a thing that I hadn't gotten to looking into, and therefore will look into it more. Like, I know of it, it's just, yeah. Oh my gosh, it's so slow. Come on. So it's just easier if I just do a search. Come on. What container runtime do I prefer and why? I've just mostly just been dealing specifically with Docker because that's what I had been using since I started dealing with containers in the first place. Haven't really ventured out of that yet. There was a little bit with Rocket back in the day, but that's obviously not a thing anymore. So yeah. Uh, can you repeat the very last part of that? Mm-hmm. Okay, so the question is like well, I can't even talk. Differentiating between dev and production. Um, and with attaching sometimes in like VS Code and it being, I guess, chaotic is a good way to put it. Yeah, I mean, like the majority of stuff that I've dealt with. So one, I'm a developer advocate and I don't do as much actually hands-on stuff with prod anymore. But mostly what I just dealt with was separation, at least in terms of namespaces for things. And then some also depending on like potentially having things running on entirely separate clusters as well. It all depends on what people want. I don't think there's a specific like right answer for how how you want to deal with the separation for it. Obviously, like if you are running on the, for instance, if you're running on the same node, if that same and not any others, if that same node goes down, both dev and prod are gone. If it's on separate ones, there's just like how much separation of concerns do you want to end up having there, and what level of communication that you might want to have. Mm-hmm. Yeah, if you, the one I have might be slightly outdated, but if you go to, not that talk. I have too many talks. If you go to speakerdeck.com/Tiffany Fay, nope, I have no internet. What? Speakerdeck.com/Tiffany Fay has this up there. And it also has the one for later tonight and /tomorrow if it seems of interest to you. Mm-hmm. Amash? Merci.